Hey, what's going on, YouTube? So, after years of running Ubuntu within my home lab, I've decided to try something new, NixOS. And I've got to say that it's really unlike anything else that I've ever used before. So, I wanted to make this video to walk you through my NixOS setup, how I migrated my Docker services over, and what surprised me overall the most about managing a system where everything is declarative. So, a little bit about NixOS. It's a distro where your entire system config lives within pretty much a single file. And rollback is as simple as rebooting, right? It's built for people who want to treat infrastructure like code, really, even in your home lab, and people who hate their lives because the learning curve for learning NixOS is very steep. And I am by no means a NixOS guru, but in this video, it's not a tutorial. There are plenty of good videos on YouTube. I'll link in the description the videos that I've used to learn NixOS so that you can get started learning yourself. But I just want to show you how I have my NixOS set up within my home lab. All right, so let's get into it. So, what is NixOS? So this will be a high overview explanation of what NixOS is, but basically it's a unique Linux distribution built around the Nix package manager, which is actually the biggest package manager or package repository with over 122,000 packages as of this year. Some features that I want to highlight. Every system is deterministic. So that means it's good on reproducibility. You can recreate your setup exactly on another machine fairly easy. Um, that also includes upgrades and rollbacks. So updates don't override your system. They're built on a new one. So if something breaks, you can roll back instantly. And then you have isolation. Packages don't interfere with each other. Thanks to NixOS's functional model, dependencies are tightly controlled. So let's go over my setup now. So I'm running 3 NixOS virtual machines inside Proxmox. Each one is declaratively defined, meaning every package, serverage, and system tweak is written out in the configuration.nix file, and I'll go over that here shortly. This pretty much gives me total control and near instant rollback if I mess something up. For orchestration, I'm using Docker Swarm. These 3 VMs, they form a small cluster that I'm mainly using for the Swarm overlay networking. My containers talk to each other across the nodes, and they're on the same network, right? And then for shared storage, I'm using NFS. One node acts as the NFS server, and then the VMs mount to it. So the services running in different containers or even across different nodes can access the same persistent volumes. And all of this is kept under version control. If I want to add a new service, change a config, or move to a new hardware, I just update my Nix files and rebuild. This home lab setup is lightweight, um, reproducible, and then surprisingly fun to maintain as well. So let's look at my configuration.nix file. So this one file basically defines everything about how the machine works, from what packages are installed to what services are running and how storage is mounting. And this is what my configuration.nix file looks like for basically all 3 of my machines, with a few differences, mainly at the top of what I'm importing into my servers. So looking at up top under my import section, I'm importing a bunch of Nix modules that define the users, services, and Docker apps. Things like traffic, get and authentic all get pulled into here and configured automatically. So if I read to build the system or clone it elsewhere, everything comes back exactly the same way. So as you can see, I have on this server, I'm running my traffic as well as get t authentic, and then Komodo. So this part of the file, this is where I set up my NFS server. So it says SDB1 gets mounted to /swarm, and then re-exported via NFS so my other nodes in the Docker Swarm cluster can access the shared volumes. And Docker is enabled natively, and I run everything using Swarm mode with overlay networking across 3 virtual machines. So I did have to set up Swarm mode the same way you would with a traditional distro. That was not done declaratively. So I went on every server, every VM, and I set up them as either a manager or a worker. So package management is also declarative too. So as you can see, I have VM, wget, zsh, self-get. All of these are installed from this list. And I never forget what's installed because it's all here. And then this section right here is really beyond the scope of this video if you're new to NixOS, but I'll touch on it briefly. Here I've enabled flakes, which adds flake support for more advanced workflows. And I'll briefly go over that when I go over my flake.nix file. And also, as you can see, I've also enabled SSH, and then I have certain ports open on the firewall as well. So now that you've seen how the configuration.nix file sets up each NixOS machine, let's zoom out and look at the file that ties everything together, and that's the flake.nix file. So flake.nix is the top level declaration that pulls all the packages, modules, and configurations that I need across my setup. So at the top under inputs, this is where I pull in all the building blocks, the unstable Nix packages channel, VS Code server support, age-based secret management. This is where I can manage my secrets. And then you have home manager for user-specific configs. The inputs define where my modules and packages come from. And now you have outputs. So this is where I actually assemble my system, right? I've got 3 virtual machines, NixOS 1, 2, and down below 3. Each of them gets their own system configs. So each VM pulls a local configuration.nix, its own personal home.nix. That's where their user configs. And then shared modules like agents, and then VS Code server. So thanks to this layout, each VM is consistent but modular. I can rebuild one or all the systems from a single command, and I always know which services are deployed where. So once I've updated my configs, deploying changes to a VM is really simple. Since everything is defined in the flake.nix file, I can just run one command to make the changes throughout all of my VMs. And that command is sudo nix rebuild switch flake, and then you'll put if since I'm on NixOS 1, I'll just put nix 01. But if I'm trying to make changes remotely on 2 or 3, then the command, you'll put the target host and then root and then the IP address. And this is, like I said before, this is a really high level explanation. There's a lot more that went to setting all of this up. I'll have all of my code within my Git repository. But like I said before, if you're new to NixOS, please, there are much better tutorial videos out there that goes over some of the basics. And then if anything breaks while you run this command, and you need to roll back, it's really easy. All you have to do is just reboot the system, and then within the grub menu, you'll just go and select a previous version of the build. And I'll just show you how that looks real quick on when you're running the command. Moving on to modules. So within NixOS, modules are how you break down and organize your system configuration into clean, reusable pieces instead of stuffing everything into one massive file. You can easily split your setup by role or service or even user, each with its own file. So within my setup, I use a module called users.nix. So within the users.nix, I have it named nano, or excuse me, nix.nix. It's used to define my user account, including what shell, SSH keys, as well as group access. Since it's a standalone file, I reuse it across multiple systems. Since all of my VMs all have the same user, just named Nix. If you wanted multiple users, then you can create multiple Nix files, users.nix files, um, per your customization. Also, you can drop in your SSH public keys so you can log in securely without passwords. There's no copying and pasting, just declare it once and then you deploy it. So, modules like this one, it let me scale my config cleanly and declaratively. If you want to add more users, like I said before, you can just duplicate the file, tweak a few of the fields, and then import it under the configuration.nix. And that's really the power of modular Nix OS, right? Now, let's take a look at how I'm running my containerized services on Nix OS. Specifically, how I declaratively manage my apps like traffic, vault warden, and image using Nix modules. So there's no manual fiddling around with Docker. There's no hidden compose files. Everything is repeatable as well as version controlled. So I'll just pull up one example real quick. And there's two ways that I've learned to run containerization within NixOS. The first one I'm going to talk about. I'll pull up my Vault Warden. So for Vault Warden, I use NixOS built-in Docker container management system, and that's under the virtualization.oci containers. Um, so this approach, it lets me define each container with its image, host name, as well as pushing out environment files and then network. Um, and this is all in Nix, right? So I specify the Docker image as well as the host name for the container, and then the path to the .env file, which holds the secrets and the configs. Um, and also I have this traffic or this container within the traffic network, and then I mount the persistent volumes under the NFS backed /swarm directory. This is lightweight, it's reliable, and again, it's fully declarative. Now, looking at a more complex container, such as image, which has multiple containers, multiple services running. So, with the image service, I continue to use Docker Compose, but as I'm using NixOS, I still want to keep it declarative. So, what I did was I wrapped the Compose command in a system service directly within my Nix config. So this system D unit ensures that the compose stack starts after Docker survives and reboots. The entire service is defined inside my Nix module, so I don't need to remember custom system control commands or rely on any shell scripts. It'll pull the latest image before running as well. So these two approaches to Docker, the native Docker config for simple services like Vault Warden, and Compose plus System D for more complex stacks such as image, it gives me the flexibility I need to keep everything under full declarative control. There's no guesswork, no config drift. By breaking Docker services into importable modules like this, I keep my setup clean, reproducible, and easy to extend. It's one of the things that makes NixOS a great choice for home lab environments, I think. So that's pretty much it for today. My journey from Ubuntu to NixOS, from ad hoc setups to fully declarative version controlled infrastructure. So I've shown you how I run NixOS across 3 Proxmox VMs, how I orchestrate my containers with Docker Swarm, share volumes over NFS, and then use modular Nix config to manage users, secrets, and services. Again, everything is clean, trackable, and most importantly, repeatable. With configuration.nix and flake.nix, I've taken the guesswork of home labbing. You want to rebuild the system, it's a single command. If you want to test out a change, just roll it back. You can roll it back in seconds, right? And by breaking services down into modules, I can scale or push back and adapt without digging through miles of config. So if you're on the fence about switching over to NixOS, I'll say this. Yeah, it has a learning curve, but once it clicks, it's hard to imagine going back to the old way, right? To imperative um, Linux distros. Thank you for following along. If this setup sparked any ideas, or you want to dive into your own home lab infrastructure or transformation, please let me know how you're building. Until next time.